All right, we're going to be talking about part 2 of our parametric equations and vectors and going through some further examples. So the next example says that a particle moves in the xy plane so that at any time t, where t is greater than or equal to 0, the position of the particle is given by these two equations. Find the magnitude of the velocity when t is equal to 1. All right, so the magnitude of your velocity, if you'll recall your formula, was the square root of dx dt squared plus dy dt squared. And once again, if you think about it graphically, the magnitude takes whatever the coordinate is for that velocity vector, and you're going to do Pythagorean theorem. All right, so the position of this is determined by two things. All right, so dx dt is going to be 2t plus 3, and then we got to square that, and then the y coordinate is going to be dy dt, which is 3t squared minus 6t, but we have to evaluate this when t is equal to 1. All right, so then that's going to give us the square root of 5 squared, which is 25, plus negative 3 squared, which is positive 9, giving us square root of 34 is the magnitude of our velocity vector. All right, so next example says a particle moves in the xy plane so that x of t, or x equals square root of 3 minus 4 cosine t, and y equals 1 minus 2 sine of t, where t is between 0 and 2 pi. Path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled. So we need to pick out some information. We're looking for distance traveled, and distance traveled is going to be the integral of the square root of dx dt squared plus dy dt squared. All right, so that is how we find the distance traveled. If we think about what we've got here, dx dt is going to be the the derivative of this, and the derivative of that is going to be positive 4 sine of t, and we got to square this. And then the derivative of y with respect to t is going to be negative 2 cosine of t squared dt. Now the next thing we need to figure out is what are the boundaries for our integral here. The boundaries are going to be right here. It says the path of the particle intersects the x-axis twice. And we got to find the distance traveled between those two x-intercepts. Now, if you think about an x-intercept, when you have an x-intercept, that means the y-coordinate is 0. And our y equation is y equals 1 minus 2 sine of t. So all we got to do is put 0 in for the y component and find out when t is equal to 0, or find out what t is when y is 0, rather. All right, so we're going to subtract 1 and divide by negative 2. That's going to give you sine of t is equal to 1/2, which means t is equal to sine inverse of 1/2. In other words, this is going to be asking at what angle on your unit circle, at what angle is your y value 1/2? Well, on your unit circle, your y value is 1/2 here and here. This is pi over 6, and this over here is 5 pi over 6. So those are the boundaries for our integral. So we're going to have pi over 6 and 5 pi over 6. And just to clean this up a little bit, this would be the integral from pi over 6 to 5 pi over 6 of the square root of 16 sine squared t plus 4 cosine squared t dt. And that would give us the distance traveled between those two times. All right, so our next example says a particle moves in the xy plane, so at any time t, the position of the particle is given by x of t is equal to this equation and y of t is equal to this equation, and where t is greater than or equal to 0, for what values of t is the particle at rest? So when a particle is at rest, we have to think about both components, because a particle could be at rest horizontally but be in motion vertically, or vice versa. And so when it says the particle is at rest, that means both components, the velocity of both components has to be equal to 0. So what we're going to do is find out what x prime of t is. That's 6t squared minus 30t plus 36, and set that equal to 0. And we're going to do the same thing with the y component. So the y prime would be equal to 3t squared minus 6t, and we got to see when that is equal to 0. So what we're checking is, when is the velocity equal to 0 in the x direction, and when is the velocity equal to 0 in the y direction. All right, so working these out, what I would do is divide everything here by 6, giving us this equation that is easier to factor down to x minus 2 times x minus 3, which gives us at t is equal to 2 and t is equal to 3, the particle is at rest horizontally. All right, so if we do the same thing over here, we can divide the whole equation by 3. That's going to give us t squared minus t is equal to 0, or, I'm sorry, t squared minus 2t. Factor out a t, which means t is equal to 0 or positive 2. Well, if you'll notice, 2 is in common with both of these. All right, so what that means is that your particle is at rest when t is equal to 2, because it's at rest both horizontally and vertically. All right, next example says a particle moves in the xy plane in such a way that its velocity vector is this. If the position vector at t equals 0 is this, find the position of the particle at t equals 1. All right, so what we're doing is starting with a velocity vector, and the question is, what is the position? Well, we get position from velocity by doing an integral. All right, so the integral of 3t squared minus 4t, that's going to give us position, which would be x of t. Well, we need to evaluate that between two t values. The t values we're looking at are 0 and 1. So that means that would equal x of 1 minus x of 0. This is your fundamental theorem of calculus. Now, we know one of these values. We know x of 0 is equal to 7. So that's the x component for position. So that's going to give us x of 1 minus 7. All right, well, we can evaluate this integral, and then we're going to add the 7 to whatever value we get here, and that will give us x of 1, the position of the particle when t is 1. All right, so antiderivative is going to give us t cubed minus 4t squared over 2, which is 2t squared. Evaluate between 0 and 1. All right, so you're going to get 1 minus 2 minus 0 minus 0. So this is negative 1. And remember, this is equal to x of 1 minus 7. So therefore, x of 1 is equal to 6. Now, we've got to keep in mind what the question is asking. It says, find the position of the particle at t equals 1. All we have found is the x-coordinate of our position. We need to do the same thing with the y-coordinate. So that means the integral of the y component, which is 8t cubed plus 5, between 0 and 1, would equal y of 1 minus y of 0. And y of 0 is negative 4. All right, so we can evaluate this. It's going to give you 8t to the 4th over 4, which reduces to 2t to the 4th, plus 5t. And this is equal to y of 1 plus 4. This part is evaluated between 0 and 1. Plug 1 in, you're going to get 2 plus 5 minus 0 plus 0. So we have 7 is equal to y of 1 plus 4, which means y of 1 is equal to 3, giving us the position vector is the x component, 6, and then the y component, 3. All right, so our next problem says that an object is moving along a curve in the xy plane, position at time t with dx dt is equal to sine of t cubed, dy dt is equal to cosine of t squared. At t equals 2, the object is at this position, 1, 4. Find the acceleration vector for the particle at t equals 2. Well, we already have dx dt, which is your first derivative. Acceleration is the second derivative. So all we need to do is take the derivative of these two things. All right, so that's going to give us the vector 3t squared cosine of t cubed, where the 3t squared is your chain rule part of this, times negative 2t sine of t squared evaluated when t is equal to 2. All right, so what we end up with is going to be 12 cosine of 8, and then negative 4 sine of 4, which would be a decimal value. You could plug that in the calculator and get a decimal equivalent for that. All right, so the next part says write the equation of the tangent line to the curve at the point where t is equal to 2. All right, so recall equation of tangent line. What do we need? We need a slope of the line, which is dy dx, which we know from our formula is dy dt divided by dx dt. And we need a point. Well, the point is going to be when t is equal to 2. All right, so when dy dx, y prime, that's going to be cosine of t squared, so that's going to be cosine of 2 squared, which is 4, over sine of t cubed, which would be sine of 2 cubed, or sine of 8. Now we also know that at t equals 2, this is the position of our particle. All right, so the coordinate that we're going to be using for position is 1, 4. All right, so that's just going to give us our equation of y minus the y value equals dy dx, our slope, which is cosine of 4 divided by sine of 8, times x minus the x coordinate of 1. That is the equation of our tangent line. All right, then part C is asking us to find the speed of the particle, the speed of the vector at t equals 2. All right, so we need to recall the speed formula, which is the magnitude of the velocity vector. So dx dt squared plus dy dt squared. And so that's going to give us the square root of sine squared t cubed plus cosine squared t squared, evaluated when t is 2. All right, so that will end up giving us sine squared of 8 plus cosine squared of 4, which is approximately 1.186 as a decimal. And the last question here says find the position of the particle at time t equals 1. All right, so once again we know the velocity in the x direction and the velocity in the y direction, so we can get the position like we did in a previous problem using our fundamental theorem. All right, so in the x direction, that's going to give us the integral from t equals 1 to t equals 2 of sine of t cubed and that's the integral of x prime, which will give us x of 2 minus x of 1. And x of 2 we know is 1. All right, so I'm just going to erase this part here and replace that with a 1. All right, so we can evaluate this on a calculator. That's a calculator question. You get 0.218 equals 1 minus x of 1, which means x of 1 would equal 0.782. All right, so we can do a similar thing with the y component, and you get integral from 1 to 2 of dy dt, which is cosine of t squared, and that would equal, and that's your integral of y prime, which would equal y of 2 minus y of 1, and we know y of 2 is 4, so I'm just going to replace this with a 4, This part, you can do this on a calculator, which comes out negative 0.443 equals 4 minus y of 1. So therefore, y of 1 is equal to 4.443, giving us the position 0.782, comma 4.443.